So when these two, coming back to parallel load, when it's 1, 1, 1, 1 implies line 3 selected, right? So at line 3, if I provide an external input, then this input appears over here if these two lines are 1, 1, right? And if I provide a rising edge on the clock now, this input which appears over here will appear at the output, at the rising edge of the clock. Do you see that? This can happen only if these two lines are 1, 1. And if I provide parallelly inputs of I2, I3, and I4, if these two lines are 1, 1, line 3 on each and every mux is selected because all of them have the same select lines, right? And all of these inputs will appear at the inputs of the D flip-flop. The output of the mux, which is the input of the D flip-flop. It will appear over here. And given that the clock, if you provide a rising edge on the clock, this input, which is the input of the D flip-flop now, will appear at the output for each and every one of them. So providing this is 1, 1, I1, I2, I3, I4 appears at Q1, Q2, Q3, and Q4. And that is a parallel load. Okay? Next. At 0, 1, it should do a right shift. Right shift implies it should move to this side. Actually, you know what? I think I was wrong. Yeah, you have to look from your perspective. This is the left shift, this is the right shift. So, at 0, 1, it should do a right shift. Right shift implies it should do basically do a right shift. Now, there are two things that have changed from what I've explained over here. Over here, I say that you are providing an external input. But over here, I'm going to say that I'm going to provide an external input of just a 0. Now, okay, right shift. Okay, what did I explain to you in this shifting process? The output of one of the inputs is connected to the next flip-flop's input, right? We're going to do the same thing over here, but obviously a right shift. So 0, 1 implies a right shift. The output of this flip-flop, the output of this flip-flop should be connected to the input of this flip-flop. The output of this flip-flop should be connected to the input of this flip-flop. The output of this flip-flop should be connected to the input of this flip-flop. So you see, if these two lines are 0, 1, if you provide some input over here, I'm providing a bit 0 always. Okay? What will happen? If I provide 0, 1, line 1 is selected on each and every one of them. What are the inputs at all these lines? The input of at this mux's line 1 is the previous output of this flip-flop. The input of this mux is the output of this flip-flop. And for this mux, it is the output of this flip-flop. So provided this is 0, 1, all the outputs are going to move to the next flip-flop whenever you provide a rising edge on the clock. Clear? Questions? Say if you do not understand, I'll explain it again. I'll try to modify my statements. But did you understand what is going on over here? Why did I connect the output of this flip-flop to the input of this mux, specifically to line 1?
Because it's in parallel, or because you want to hold it?
Yes. No. We are not holding on to the value. Hold is just this.
I thought that's what you're
0, 0.
What were you pointing to?
I was pointing to this 1. Why is the output of another flip-flop connected to the input of this one, specifically to line 1.
You're shifting the position.
We're shifting to the right, and in this we are supposed to do a shift right only if the inputs S1 and S0 are 0, 1. And when these two inputs are 0, 1, line 1 is selected. Okay? Now, 1, 0 implies a left shift. Left shift implies that the output of this flip-flop should be the input now. Your inputs are 1, 0. 1, 0 implies line 2 is selected. And you want to do a left shift. So the output of this flip-flop should be the input of this flip-flop specifically on the line 2 over here. So the output of this flip-flop should be the input of this flip-flop. The output of this flip-flop should be the input of this flip-flop. And I'm providing an input of a bit 0 over here. And that's why I wanted you guys to work on this, because this is a little confusing once it's completed. But if you follow step by step what we're trying to do, it's not going to be that difficult. So try to draw this right. Now what is happening over here? When it's 1, 0, the output of this flip-flop, which is over here, is connected to the second line of this flip-flop. So when it is 1, 0, this line is selected, and this line has an input of the previous output of this flip-flop. That is connected to the input of this D flip-flop, and at every rising edge of the clock, this output, which is appearing over here, will become the output over here at that clock pulse. So, what does this look like? Assuming, let's just say you do this. Follow these sequences and you'll probably see some changes. First, provide an input of 1, 1. Okay? And a parallel input of 1, 0, 1, 0. When you do this, when you provide the select lines to be 1, 1, line 3 is selected. Line 3 is selected implies I1, I2, I3, I4 are selected. They appear as these lines over here. Okay? And of course 1, 1 and a rising edge on the clock. So this is S1, S0, and this is the clock. I'm providing an input of 1, 0, 1, 0 on I1, I2, I3 and I4. So if S1, S0 are 1, 1 and there is a rising edge on the clock, the output Q1, Q2, Q3, Q4 will have 1, 0, 1, 0 because you're doing a parallel load. And this happens only at the rising edge of the clock. Okay? This will not happen if the clock is 1 or a 0 or a falling edge. It happens only if this is a rising edge of the clock, because that's how we have to design it. Now, if next I do let's say a 1, 0. 1, 0 implies it's going to do a left shift. That means all the bits are going to move to the left. Okay? So, the output right now over here, Q4, is 0. 0, 1, 0, 1. Assume that this is Q4, Q3, Q2, Q1. So Q4 is 0 right now. Q4 becomes the input of this D flip-flop because I've provided the select line to be equal to 1, 0. Okay? That means at the next rising edge of the clock, this bit is going to appear over here. This bit is going to appear over here. This bit appears over here. And an external 0 appears over here. Do you see how all the bits have moved to the left and an extra 0 has been added to the end? That's basically your left shift. Okay? Now, what if I provide another 1, 0 and a rising edge on the clock? These are the current bits at the output, and these are provided as inputs to the flip-flops. So 0 moves over here, 0 moves over here, 1 moves over here, and an extra 0 is added over here. Do you see that? Do you see how this is happening? Each and every bit is moving to the left one bit at a time. Now if I provide a 0, 1 and a rising edge on the clock, when I provide 0, 1, the current state is 1, 0, 0, 0. Okay? 0, 1 does a right shift. That means this bit is going to move over here, this bit is going to move over here, this bit moves over here, and an extra 0, since I've connected a 0, will appear at the output Q1. So now all the bits have moved to the right by 1 bit. This happens only at the rising edge of the clock. Okay? Not any other time. Now, if I provide a 0, 1 again and a rising edge, this is the current state of the flip-flops. So this 0 moves over here, this 1 moves over here, this 0 moves over here, and an extra 0 comes over here. So now your output should be 0, 0, 1, 0. Okay? Now if I provide a 0, 0 and a rising edge of the clock, this is the current state of your Qs. This 0 is provided as the input to this mux, which is the input to the D flip-flop. Since S1 and S0 are 0, 0 over here. So at the rising edge of the clock, this 0 appears at the same place, this 0 appears at the same place, this 1 appears at the same place, this 0 appears at the same place. Because this, which is the current output, is provided as the input again, over here. This is provided as the input over here. Since these two lines are 0, 0, they appear at the output, and so D is seeing what is the current value of this. So when the rising edge of the clock takes place, the same value appears at the output Q. And that's why they are holding on to the value. Yes?
When you tell a clock, or when do you know to change on the rising edge or the falling edge? So like program that.
I will show you how to do that when I'm showing that one. Is this clear? Is this clear what I'm trying to do over here? Yes.
Is it okay to treat, when you have zeros in the first and fourth muxes to take the place of, to give value as you shift left and right? Is it okay to set that? Are you expecting that, I guess, to set as 0? Or
We don't have enough switches, and that's why I haven't, I'm asking you guys to set it to a specific value. But you can have, what it basically is doing is giving you a way to get serial data and put it and store it in the memory.
So it's because we're limited with the number of switches that we
Yeah,
have.
it's the limitation of the board, because of which I'm asking you to do this. Otherwise, if you see the number of ports you would need is 1, 2, 3, 4, 5, 6, 7, 8, 9. We have just 8 switches. So that's why I'm just putting a value of 0. And that's why I say that initially give a 1, 1 to set a specific output, and then you can see the LEDs moving to the left and the right and things like that. Okay? Is this clear? Please ask questions. Okay, I guess it's clear there. Yes.
If like some problems that we need go to ask us like do we the same thing adding the 1 instead of 0 like on the left on the right. I mean why is that happen or
Yes.
like, and
You
how
can give any input over here. You can connect this to a specific line and provide a series of bits on that, 1, 0, 0, 1 and stuff like that. It's just that what would happen is if I provide an input, say I prime over here, which has an input maybe say 1, 0, 1, 0, 1, 0 or something like that.